I'm Patty Simpson with Simpson Math. Let's learn about factorials. So a factorial is just another operation. Just like if you see a plus sign, you know that that means that you're going to combine the numbers. You're going to take 3 and 2 and put them together. That's an operation that tells you what to do with your numbers. Or for instance, if you have something like a square root, you know that you're looking for, this is an operation where you're looking for a number that multiplies by itself to give you 16. A factorial is just another operation. And we show a factorial with an exclamation mark. This exclamation mark means factorial in mathematics. So a factorial is just the product of every number from 1 up to whatever number it is that's in front of your exclamation mark. That's all that factorial means. So this factorial, we read it as 7 factorial. And that 7 factorial, this exclamation mark right here, just means to take the numbers 1 times 2 times 3 times 4 times 5 times 6 times 7. I'm just going to multiply those numbers all the way up to 7. And then I stop there at 7. So I have 1 times 2 is 2, times 3 is 6, times 4 is 24. We're starting to get a little bigger now. 24, well, 5 times 6 is 30. Well, and times 7 is 21. So we could say 210. And then we multiply those two numbers together. So it ends with a 0. And you have 4. And 8 and 2 is 10. Carry your 1, 4, 5. So that equals 5,040 if we multiply all those numbers together. So 7 factorial is equal to 5,040. It's just the numbers 1 times 2 times 3 times 4 times 5 times 6 times 7. We can also write it in descending order. And most of the time we do. When we talk about factorials, most of the time we actually write them in descending order like this. We say 7 times 6 times 5 times 4 times 3 times 2 times 1. And then on bottom of this fraction, notice I have 5 factorial. Well, 5 factorial is just counting from 1 to 5. Or we could count it in descending order starting at 5. 5 times 4 times 3 times 2 times 1. Now notice when we have that 7 factorial over 5 factorial, that here I have a 5 on top and a 5 on bottom. Those cancel, or they become 1. The 4 divided by 4 is 1. The 3 divided by 3 is 1. The 2 divided by 2 is 1. The 1 divided by 1 is 1. And I'm just left with 7 times 6. But let me show you another way to write this. Instead of writing it all the way out, I could have stopped. I could have written 7 times 6, and then this 1 times 2 times 3 times 4 times 5, or this 5 times 4 times 3 times 2 times 1, I could have written as 5 factorial. This means 5 times 4 times 3 times 2 times 1. This is the same thing as what I had written over there. Now, on bottom, I don't have to write that out. I just have 5 factorial on bottom. Notice it's the same thing on top as it is on bottom. So I could have just stopped. I could have written 7 times 6 times 5 factorial, and this 5 factorial divided by that 5 factorial becomes 1. So I have 7 times 6 either way, which gives me 42. As our problems get more and more complicated, this may be handy to do so that we stop at a number so that we can cancel out or simplify. Let's do another example. Here I have 7 factorial over 5 factorial and 2 factorial down there on bottom. So I'm going to use that same trick I just did, where I do 7 times 6 times 5 factorial. Because I know that this 5 factorial and that 5 factorial are going to cancel out. But I didn't keep going down to 2 times 1. So this 2 factorial is still 2 times 1. I have to have him on there as well. So this 5 factorial and that 5 factorial will cancel out, or they will become 1. But I still have a 7 times 6 over a 2 times 1. I have 7 times 6 over 2 times 1, which is just 2. Again, I'm going to simplify before I multiply. So this 2 can go into that 6 3 times. So now I'm just multiplying 7 times 3, which gives me 21. Let's do this one. Here, I need to do inside the parentheses first. So I have 7 minus 2, which gives me 5. And that factorial is on the outside. So it's 5 factorial. And there's still a 2 factorial there being multiplied. Now, I'm going to simplify again. So I have 7 times 6 times, I'm going to stop at that 5 factorial. And that's the same as what I had before. So the 5 factorials cancel, the 2 goes into 6 3 times, and I still have 21. We're going to use these factorials to help us with something called counting, where we're looking for how many different ways we can collect a group from a larger group. And we're going to use these factorials to help us with that. Math Made Simple is some math. Thanks for watching.